All right, let's dive into a cosmic detective story. We're heading way out, nearly 9,000 light years from Earth, to investigate a star that, by all accounts, really shouldn't exist. It's a fantastic puzzle that challenges pretty much everything we thought we knew about the lives of the most massive stars.
You know, in astronomy, you can think of star clusters as these big family portraits. See, every star in the picture was born from the same cloud of gas and dust at basically the same time. But in this particular family, there's an outlier. A star that seems to have found some kind of cosmic fountain of youth. It's brighter, it's hotter, and it looks way younger than all its siblings. So how on earth is that possible?
Our scene of the crime, if you want to call it that, is this brilliant star cluster, NGC 6633. It's also known as Caldwell 10, and you can find it up in the constellation Cassiopeia. This place is what we call a stellar nursery, just a bustling city of young, incredibly hot stars.
And let me tell you, this is no ordinary cluster. NGC 663 is an absolute heavyweight. At 25 million years old, it's just a teenager in cosmic terms, and it's one of the most massive clusters in our galaxy's Perseus arm. It's home to over 300 of these huge blue B-type stars, and that includes dozens of a really peculiar variety called B stars, which are spinning so fast they're basically on the verge of tearing themselves apart.
So, right here, inside this massive and otherwise pretty well-behaved stellar family, we find our rule breaker.
And this is the central paradox, right? It's the big question. In a cluster this age, the most massive stars should have already burned through all their fuel. They should have evolved past their stable adult phase. They should be swelling up, cooling down, getting old. And yet, this one star is still just blazing away, furiously blue and hot, looking far more massive and way younger than the cluster's age should even allow.
Astronomers actually have a name for these cosmic misfits: blue stragglers. They're stars that seem to have, well, straggled behind all their peers on the evolutionary timeline. They totally break that fundamental rule of a star cluster's family portrait. And finding one is always the start of a really interesting story.
So, our blue straggler has a name, LSI plus 61 degrees 235. Now, on its own, it's an impressive B-type star, for sure. But when you see it in the context of its 25-million-year-old home, its youthful glow is a dead giveaway that something very, very strange happened in its past.
And what's really fascinating about this whole case is that our suspect wasn't acting alone. Nope, it has a partner. And it's a truly bizarre one, which helps complete the picture of this cosmic odd couple.
The whole system is what we call a B X-ray binary. So let's break that down. First, you have the B star. That's our hot B-type star that's spinning so fast it's literally flung a disk of its own gas out into orbit around it. Then orbiting that, you have a compact object, in this case, a neutron star, which is the super dense corpse of a star that already exploded. As that neutron star flies around, it steals gas from the B star's disk, and all that stolen material heats up and glows like crazy in X-rays.
And our blue straggler, LSI plus 61 degree 235, is an absolute beast. We're talking about 11 to 14 times the mass of our own sun, 7 times the radius, and it's blazing away at a surface temperature of 24,000 Kelvin. That makes it way more massive than any other star still in its stable main sequence phase in this entire cluster.
And its companion? Well, that's the leftover remnant of an even more massive star that has already lived its life, died, and gone supernova. A neutron star. And this bizarre pairing, that's the key to the whole mystery.
Okay, now here's where things get really, really weird. We can measure the neutron star's spin, its pulse. And get this dead star is rotating so incredibly slowly, it takes a full 25 minutes to complete just one rotation. For a neutron star, that is astonishingly slow. I mean, it is the slowest ever found in this type of binary system, period.
And this chart just brilliantly illustrates how weird this whole system is. Most B X-ray binaries have violent places. They've got these wacky, egg-shaped orbits and produce these huge, dramatic outbursts of X-rays. But our system, which we call RxJ0146.9 plus 6121, it's calm. It has a wide, almost perfectly circular orbit and just emits this steady, low-level glow of X-rays. I mean, everything about it is just unusual.
So, how in the world does such a strange, calm system even form?
The answer, ironically, lies in a violent but very, very specific cosmic history.
The story goes a little something like this. Originally, you had two massive stars born together as a binary pair. The more massive of the two burned through its fuel faster. As it started to swell up, its gravity wasn't quite strong enough to hold on to its outer layers, and its smaller companion began to siphon off or feed on its gas. This whole mass transfer acted like a cosmic fountain of youth. It rejuvenated the smaller star, making it more massive, hotter, and bam, turning it into our blue straggler. Eventually, that donor star, now just a stripped-down core, exploded as a supernova, leaving behind the slow-spinning neutron star we see today.
Now, usually a supernova explosion is so powerful it gives the newborn neutron star a massive kick, and that can totally break the binary system apart. But here, all the evidence points to a surprisingly gentle supernova. The system is still tightly bound in this nearly circular orbit, and it's moving away from the cluster center really slowly. It's what we call a walkaway star, not a high-speed runaway. It all suggests the explosion gave it just a tiny little nudge.
And while all that cosmic drama was happening, the B star itself has its own rhythm. This plot here shows how the light from that gas disk around it varies over time. It effectively breathes, going through a full cycle about every 3 years. And this is a property of the star itself, this slow oscillation in its disk, totally separate from the influence of its neutron star buddy.
So, okay, we've got a stellar vampire, a gentle explosion, and a slow-spinning zombie star. What does all this mean? Why does this one system matter so much?
It all comes down to one simple, absolutely crucial fact. This is the only X-ray binary we know of that lives inside a galactic open cluster. This is huge. It turns the system from just a cool curiosity into a perfect scientific laboratory.
And here's why that is so important. Its location inside a cluster with a known age is what proves it's a blue straggler. It's not just a guess. This lets us test our theories about how binary stars evolve with incredible precision. We get a living, breathing example of a really rare evolutionary path, giving us this unique snapshot that helps us piece together the life stories of the galaxy's most massive and influential stars.
It really makes you wonder, doesn't it? Every single star in the sky has a story. This one just happened to have a witness, the cluster it grew up in. And it leaves us with this tantalizing question. How many other dramatic life stories, cosmic crimes, and strange partnerships are written up there in the stars, just waiting for us to find the right clues to decode them?